And I think all of us have heard a lot in the news, if nowhere else, about global warming or climate change. And this isn't my specialty, not at all. But I'm a marine geophysicist, and I've worked in the Far East for a few decades. And I would rather be talking about subduction zones and tectonics of plates moving and crashing together. That's a lot of fun. But this darn topic about global warming and climate change has become a real societal issue. And so it has caught my attention. And I'm a little frustrated that there's not much geologic evidence or observational evidence that gets included in the discussions that are taking place. There is an awful lot of modeling, but things are a little short on observations that might be important, historical observations and geological observations. So I want to very quickly talk about some rather long-term observations and then some short-term observations. And I'll go through very fast. This comes out of a textbook. Everything that I'm presenting comes from basically two sources. The first few slides come out of the textbook by Skinner and Porter, and it's called The Dynamic Earth. And they did a very nice job in this textbook about summarizing some of the factors that can be related from geological sciences to what our cooling and warming history has been, our history of glaciation and periods of interglacial periods. Well, this is a good starting point. This is the record from coring, deep sea cores, back to about 2 million years. This is coming mostly from the ocean drilling program, deep sea drilling program, etc. And the sediments are dated. And then sediments are dated, and then the oxygen isotope ratios of oxygen 18 and 16 are examined. And those ratios, the ratio of oxygen 18 to 16, can be translated right into past temperatures. So we have, through the oxygen isotope ratios, a way to get at what the past temperatures were as we go down through sediments of continuous deposition. So we have a complete geologic record going back. It goes further back. We've got a lot of history of glaciation and interglacial periods before this, but this gives us a very interesting record of what the temperatures or what the amount of glaciation has been in the past. And basically, this is glaciation, and these are interglacial periods. Here we are up here. This is present time. And we're at about the peak, or maybe a little past the peak, of this interglacial period. You can see that the frequency of glacial period to interglacial period is different down to about 1 million years. Past 1 million years back to about 2 million years, the frequency is higher. Here, the frequency of a glacial interglacial cycle is about 100,000 years. Okay, about 100,000 years. Now, this is just all based on sediment sampling and temperatures calculated from the oxygen isotope ratios. But here's a good record of glacial, interglacial periods and frequencies. Next slide. Now, why should we have glacial and interglacial periods? Well, this is just a quick look at what are called the Planck cycles. And what this is fluctuations in the orbital parameters and motion parameters of the Earth about the Sun. And we don't follow a nice simple, we're not just simply a round ball going around the Sun. Uh, we have precession of the equinoxes taking place, and that's due to wobble of the Earth's axis, and it's also a additional rotation of the Earth's axis. And what this does is cause there to be a systematic fluctuation in the where the equinoxes occur on the surface of the Earth, okay? And that period turns out to be about 23 million years, or 23,000 years, sorry. Geologists like to talk in millions of years. Next slide. We have another thing that's taking place as we go marching along around the sun, and that is we have a change in the tilt of the axis of the Earth, and that has a period of about 41,000 years. And then the last thing we have is our orbit is not perfectly spherical. It goes from more spherical to more elliptical and back. And the period for this taking place is, about 100,000 years. Next one. Here they are plotted against time back to 800,000 years. Here's the eccentricity of the orbit. Here's the tilt. Here's the precession. And here's the combined, these three signals combined. Okay? And this is important because all those motions affect the radiation that arrives from the sun on the Earth. It changes because of these changes in motion. And how do we know that? Where do we see this? We see it right over here. This is the oxygen isotope ratios, or a temperature record. This is what I showed you in the first slide. It's just at a different scale. Notice, combined signal of radiation received at any place on the Earth, okay, goes up and down according to this type of fluctuation. Gee, those curves look a lot alike, don't they? This is the primary evidence for relating the glacial and interglacial periods to the primary motions of the Earth about the sun. Next slide. This is taking a look at ice core data from Antarctica, and this is for a much shorter period, 160,000 years. We have three things that are presented here. One is the change in temperature from present, and this is based on oxygen isotope data again, out of the gases that are trapped in bubbles in the ice as glaciers build up. Well, here's our present interglacial period. Here's the glacial period, past interglacial period, and then another glacial period back here. And you can see there looks like the period going from glacial to interglacial. That adds up to about 100,000 years. Just like the cycles that we saw based on the length of cycles. We come up with a combined periodicity of about 100,000 years. There's fluctuation in some of these numbers, but that's sort of an average. But look here, we have temperature up here. Here's where we are now, okay? And we can also see that for these periods, there's been for this period of time, there's been a fluctuation in temperature somewhere between 4 and 10 degrees C generally through these last two interglacial glacial cycles. But here's carbon dioxide. Gee, there's a record that looks a lot like the temperature record. Here's methane, a record that looks a lot like this. Gee, if I look at this type of data and I say, did the carbon dioxide come first or did the temperature Did the methane come first, or did the temperature come first? Basically, they're in harmony. They change together. Okay? Now, this is what we see from about a 2 million year geologic record. We see it from the ice core data record. But this type of stuff doesn't get talked about when we talk about climate change or global warming. And it should, and we should have more research taking a look at the geologic record. These type of data should be incorporated into modeling that's done, and generally they're not. Next slide. Now this, and the next few slides, do I have 5 minutes yet?
Sure.
Okay.
Yes.
My student said yes. These data, that figures I'm going to show you, come from a paper. Some of you may know about it. It's by two research scientists at the Oregon Medical Research Institute. And an additional guy named Willie Soon, who is not a medical doctor. And he focuses on solar science and fluctuations in energy from the sun. They took a look, and I suspect that they got started because they were at a medical research institute. They got started looking at what's going on in the atmosphere with CO2. But they expanded. And they published a paper in which they're comparing a lot of things to the occurrence of hydrocarbon use by man, okay? And we've got coal, oil, and gas, and this shows, you're going to see this on several figures. It shows the increase from essentially zero back in the early 1800s up to the year 2000 here. And they did a very thorough review. They referenced 132 publications for this paper. These include things like JGR, Geophysical Research Letters, Nature, Science, Climatology, so on and so forth. And they did a very thorough job, and they went and looked at a lot of good related research. Well, the first one is, this is before hydrocarbon use. This is during the increase in hydrocarbon use. And here we have the plot of glacial shortening, okay? Well, that really started back here just 1820 or something thereabouts. And we've had glacial shortening going on since then. Well, what's glacial shortening related to? Temperature increase. Okay, the temperature started to increase down here well before there was any significant use of hydrocarbons. The temperature started to increase first in recent time before we had any significant use of hydrocarbons. Next slide. This is a plot over the same period of time here. Here again, we have the world hydrocarbon use and coal coming first, and then oil, and then gas, and so on. And what we have a plot up here is Arctic air temperature, and we have a record also more primitively discovered or determined in the earlier time, but now in more recent time, more determined in more sophisticated ways. But this is solar irradiation, okay? And this is the temperature record for Arctic air temperatures. Some interesting things, just quickly. Okay, we have a rise in solar activity, we have a rise in temperature. Now we're coming to a real rapid increase in use of hydrocarbon when we have solar activity and temperature declining. There's a dip here, okay? And then it's going back up. So this trend is continuing, and it's steepening, and here we have a big bump, fairly big bump, and it's worth a degree or two C over here. Next slide. This is the trend in U.S. surface temperatures in the contiguous 48 states of North America, part of U.S. North America. And this is fluctuation in surface temperatures, the blue curve, and this is the best fit through this, and it's a trend of about 0.5 degrees C per century. Well, I'm not saying there is no global warming. We are in a global warming period. We're in an interglacial period, and we're based on past history, we're about at the peak. Hopefully we'll go to the top and it'll cool off a little bit. But here are these trends again of increasing and decreasing intermediate trends, and this reflects what we saw with the Arctic data, where it was related to the solar energy fluctuations as well. Next slide. Here is the same thing with the solar activity plotted on top of it. Next slide. Okay,